Okay, so today in class we're going to go over your guided reading that was assigned for Chapter 3, Lesson 1. Number 1A1, the periodic table is a chart of the elements arranged in rows. Rows go horizontal, and columns go vertical according to their chemical and physical properties. So physical properties go horizontally, and chemical properties, and we'll find out why soon, go through the columns. The chemical property stays pretty much the same all the way down the column. All right, B1, in the mid-1800s, Russian chemist and teacher Mendeleev created a table to help classify the elements by their properties. And remember in the video yesterday, they showed how he did that. He put everything they knew about the 66 elements that they knew at that time on cards, and then he was messing with the cards trying to figure out if there was a pattern, and he saw a pattern. The pattern was so accurate that he was able to predict 3 unknown elements and what their properties would be and what their masses would be, and he predicted very accurately based on his 66 that they knew. So that was good stuff. He placed the elements in rows of increasing atomic mass. We now know that that's not as accurate. Moseley came along and did it by atomic number, which we know is the number of protons. But there's only a few places on the periodic table where doing it by mass would be wrong. And that would have the wrong periodicity, which is a repeated pattern along the horizontal row. Okay. All right. The elements in the periodic table showed repeating patterns. Periodic is a word used to describe such patterns. For example, Mendeleev noticed patterns in the properties of elements. The temperature at which a solid changes from a solid to a liquid. Remember, that's a physical property. So that was going along the horizontal row. The period. The period is periodicity, a repeated pattern. Of physical, they all start with P. All right. Number 2, after arranging the known elements in a periodic table, Mendeleev noticed large gaps between elements. He predicted that scientists would find elements to fit into those spaces. Mendeleev's predictions were true. Number 3, in the early 1900s, Henry Moseley found that the problem with Mendeleev's table could be solved if the elements were arranged in rows by an increasing atomic number, which is the number of protons. So it increases by 1 each time. So it's a very nice pattern. Okay. Number 4, the atomic number is the number of protons in the nucleus of an atom of an element. And C, number 1, you can identify the properties of an element by studying its placement on the periodic table. So for example, Continental Steel, which is now Haynes, they've made stuff for NASA. And they understand the metals and their positions on the periodic table, and they would mix certain metals to create certain properties based on their placement on the periodic table. So they would mix these metals and try to get them to come together and create new alloys with the properties that they needed. Maybe they needed it to be strong and light, so then they would want to use the lighter side of the periodic table. Okay. 2C2, the element key shows the element's name, atomic number, chemical symbol, state of matter, and atomic mass. And in your book, this key is not as user-friendly. It's a little more advanced. Your book has a great key, okay? So on page 86, it tells you the element name, the atomic number, the symbol, and always make sure you write the symbol correctly, exactly as you see it. And then the atomic mass, the average atomic mass is really what it should say. Then the state of matter at room temperature, and it has little symbols. So a gas is in a balloon, so the balloon looking thing is at room temperature, it's a gas. And if it's a liquid at room temperature, which there aren't very many, It looks like a water drop. And then the solids, which are the majority, are going to be a little block. Looks almost like a sugar cube. And then the synthetics, those synthetic means man-made. They're a circle with a circle inside the circle. So those are made in laboratories. Okay. And then over here on page 87, you need to know whether they're metals. Most of the periodic table is a metal. See all the blue boxes? The background color tells you whether it's a metal, non-metal, which are mostly gases, metalloids, which are your semiconductors. They're used for semiconductors because they're metalloids. They have a little bit of metal property and a little bit of non-metal property because they're the boundary between the two. Do you see that in the pattern? Okay. And then recently discovered ones, they don't know exactly what their properties are. They have a gray background. So whenever you're doing content practices, don't use online ones. Use this one because the answer key and everything is based on this one. Okay? All right. And you're going to be doing stuff today with that. That's why I took a moment to go over those, because you need to be able to read this information. You're going to do some stuff with it today. Number 3, a group is a column. So it's the verticals, groups, and they have group numbers above them. There are numbers above them. This is group 3, this is group 4, this is group 5, this is group 6. There's numbers to the side which tell you your period number, okay? So in your book, they're actually numbered. I hand wrote this one. So period 1 goes that way, period 2 goes that way, period 3, the row that goes that way, period 4 starts with potassium and goes that way, okay? So those are your period numbers because they number the periods, which are horizontal rows. And then the group numbers also have the groups also have numbers, and they're above the columns, which are vertical. All right. Elements, number 4, elements in the same group have similar chemical properties, which means they react with other elements in similar ways. And it has to do with the electron placement. Number 5, the rows on the periodic table are called periods. The rows, horizontal. As you read from left to right across the periodic table, atomic number increases by 1 for each element. So let's go down to this one. Let's start in this row. Potassium is 19, calcium is 20, scandium is 21, titanium is 22, vanadium is 23, and so on. It increases by 1. Atomic number increases by 1. Most of the elements in the periodic table are metals, which are shiny and conduct thermal energy and electricity. Number 8, most nonmetals are on the right side of the periodic table. These elements do not conduct thermal energy and electricity because they are not metals. They do not have metal properties. And those are going to be, these are your nonmetals. And the only one that's not over there, that's not over here, is hydrogen. And it's over here because it's highly reactive like all of this group. That's why it's over here. And it's element number 1, so you got to start with 1. Okay? Number 9, between the metals and nonmetals on the periodic table are the metalloids. We sometimes call them the zigzag or the stair step. So you can see them here in the red on this one. In your book, they're colored green. So the zigzags / stair step, right? And D1, scientists use the periodic table to predict the properties of the new elements they create, and to elements that are near each other on the periodic table share similar properties because it's a repeated pattern. And the property just gradually changes as you move across. All right? So the activities that you're going to do today, you have 2 content practices. One of them, this first one I'm going to go over with you, okay? It says, for example, carbon. What is the atomic number? So you find carbon on the periodic table. It's right over here. That's carbon. The atomic number is 6. So you'll put a 6 there. Is it a metal, non-metal, or metalloid? So when you use your book one, okay? The background color will tell you that, remember? Use your keys. You have your keys on these 2 pages. You have your keys. And carbon has a yellow background, so that means it is a non-metal. Carbon is a non-metal. And then it says what state of matter is it in? Carbon has looks like a sugar cube, so therefore it's the little white sugar cube. Therefore it's a solid. So it's a solid at room temperature. And where is it? And you have to write the period number and the group number underneath it. So periods go this way. So carbon is in period 2, and it's in group, see the number right above it? There's a 14. It's in group 14. So you'll write period 2, which is your row, and group 14. Okay? So that's how you're going to do that paper. And then the other content practice of the periodic table that you're going to do is matching. Okay? Use your book to help you and get your matching done. All right? So in class, when the kids finish these in class, we're going to go over the answers. So if you're not here today, go ahead and email me them, and I'll look at them real quick and give you some feedback just to let you know how you're doing, okay? These are important. You're going to be taking a quiz over these next week, probably Monday, if we're here. If the snow comes and we're not here on Monday, then you'll take it on Tuesday, okay? So there'll be a quiz over Chapter 3, Lesson 1, our first day we're here next week. So who knows what we really get, because it's Indiana. The forecast might change. So might get better, might get worse. So have a wonderful weekend.